Looking at this problem, you might realize that it has a similar vibe to a previous one we did, namely that it required a U substitution where U is equal to e to the x. Okay, well, that's all well and good, and then if U is e to the x, that's fine. Then du is also e to the x dx. Interesting. But e to the x there is in the numerator, and I don't have it in the numerator. Sneaky. Okay, but let's think here. I have the dx in there. So what I really want is the dx. So wouldn't 1 over e to the x du be equal to dx? Now I know what you're thinking. Alana, you can't mix x's and u's. Correct. But e to the x is u. So this is 1 over u du is equal to dx. That's a sneaky substitution, right? So that's a tricky u sub. But it's tricky. All right, so let's put that in. So that means that our integral is equal to the integral of du. Well, let me put it this way. Let me go 1 over that e to the x is u, and then square root 1 minus u squared. And then dx is going to be written as 1 over u du, right? So there's your e to the x, there's your square root 1 minus e to the 2x, and there's your dx right there. Oops, sorry, I wrote on the paper. Now, that got us there. Wonderful. Let me put those two u's together because they're both in the denominator. So this is really this integral of 1 over u squared, because u times u is u squared, square root of 1 minus u squared du. Now at that point, you're wondering, what am I going to do? What am I going to do? Well, I seem to recall that we had a technique that said, hey, if it fits into this format, you have to use a substitution. But it's not a U substitution. It's a trigonometric substitution, right? So let's go back to that page. It was a while ago. So if it's 1 minus u squared, if your integral contains 1 minus u squared, a squared minus u squared, it's this trig substitution. It's the sine of theta one. Okay, so let's go figure out all that glorious stuff that we love for trig substitution. So that's our second technique. So this was technique number 1. So technique number 1 got us to this point, right? Got us to here. Oh, I don't want to put it up there. It makes it seem like it's my limit of integration. So let me just say technique number 1 gets us here. Okay, now we need technique number 2. And that will be trig substitution. Okay, and the trig substitution we are going to make is that the sine of theta is equal to u over 1. You'll notice that a is 1, right? So a squared here. I'll just make a little note before I even write that. So we'll note that a squared is equal to 1, so that means that a is equal to 1, and so that means that our trig substitution is that the sine of theta is equal to u over 1. There's our trig substitution. Okay, from there we can build a triangle. Oop, a very wobbly triangle. Goodness, my paper must have wobbled on me. Okay, at least that's my story and I'm sticking to it. All right, so there's my angle theta. Sine is, of course, opposite over hypotenuse. So that's u, that's 1. Using the Pythagorean theorem, this would be 1 minus u squared, right? Because this squared plus that squared must be equal to 1. Feel free to use the Pythagorean theorem to prove it if you want. All right, so sine of theta is equal to u over 1. That means that u is equal to the sine of theta, right? And that means that du is equal to the derivative of that, which would be the derivative of sine is cosine of theta d theta. And that also means that theta is the arc sine of u. Technically it's u over 1, but you know, it all works out, right? All right, so let's go substitute in. And I'm going to, of course, separate my paper out. So I have all my by hand work over here. So I got technique 1 there, technique 2 here. Now I'm going to go substitute into this thing. So this is equal to, okay, 1, I can do that, over u squared. U is the sine of theta. It's right here. Right? There's your sine of theta piece right here. So I'm going to use that. And I'm going to use this for du. Right? So wherever there's a u, I'm going to put sine of theta. When there's a du, I'm going to put cosine of theta. So I'm going to say sine of theta, or sine squared of theta, right, because it was squared, square root 1 minus sine squared of theta in here. And then du was the cosine of theta d theta. Right, this was the first substitution, right, those two, and then this is the second one. It goes right there. All right, now I know what you're thinking. That did not make things better. Oh, but it did, because 1 minus sine squared should be setting off little alarms in your head. That has an identity. So this is 1 over sine of squared of theta, square root of, and then 1 minus sine squared is cosine squared. So that's a Pythagorean identity. That's going to turn into cosine squared. Right? And then it's still multiplied by a cosine out here. Or I could put it up on the numerator. It doesn't really matter where I put it. But okay, well, the square root of cosine squared is cosine. So this is equal to 1 over sine squared theta, and then the square root of cosine squared is cosine of theta, and then I have another cosine of theta outside. Sorry, I lost my colors. I couldn't bear it. I had to have them back. All right, so then this cosine that's in the numerator, because this blue one is in the numerator and this pink one in the denominator, they're going to divide away to 1, so that's going to be gone. So then I'm left with the integral of, now I'm going to lose my colors, 1 over sine squared theta d theta. But 1 over sine squared, by definition of cosecant, right, by the cosecant identity, is equal to cosecant squared. Right? And then the integral of cosecant squared, that should be setting off bells because we know that from our quick reference sheet. Cosecant squared is negative cotangent. So this would be negative cotangent of theta plus c. Now, this is not the answer because this is in terms of theta. If you remember, our original problem is in terms of x. So we need to get back to x. All right, so my first mission is going to be to get back to u. Right, so let's go back here and look at for the cotangent. Cotangent is adjacent over hypotenuse, right? Because tangent is opposite over adjacent. So the cotangent of theta, look at your triangle. Cotangent of theta would be the square root of 1 minus u squared over u. It's adjacent over adjacent over opposite. Okay, so just use that. So then this is negative square root 1 minus u squared over u plus c. And there was a negative there in the front, so it's still sitting there. And now go back in with what u was. That would be negative square root 1 minus, and then u was e to the x. So this would be e to the 2x over e to the x plus c. Two different substitutions, a U-substitution, then a trig substitution. And then at the very end, we end up with a trig answer that we have to change into a U answer, which then we have to change into the original e to the x answer to get our original variable back.